Good day. So, is it you going to present today, or you just to watch?
Can you hear me?
Yes, I can hear.
Okay. I'm going to make the presentation for OpenCruise.
Okay, I would suggest let's wait for a couple of minutes. Let's get a chance for people to join. If not, when we can just start, the recording will be available to everyone. But
Okay.
first of all,
Okay.
let's wait a few minutes for others to join.
Okay.
All right, I think we can start. So Ricardo unfortunately is not available today, so I will be chairing this meeting. So welcome everyone to the TAG-Runtime community meeting. Today is 7th of April. And today we have only one item in the agenda. It's OpenCruise presentation. And Sil, the floor is yours. You can start presenting, and recording will be available to everyone on our YouTube channel.
Okay. Let me share the screen. Okay. Can you see this?
Yeah, looks good.
Okay.
Go ahead.
Okay. I'm Siyu Wang. Okay. Zheng Zhang is also OpenCruise maintainer. Actually, we have more maintainers and members that should be interested in this, but most of our maintainers and members comes from China, and you know it is 11 p.m. In China, so they may be inconvenient to attend this. Okay, so I'm just start my presentation. First, I would like to introduce what is OpenCruise. OpenCruise, it is an extended component suite for Kubernetes. It mainly focuses on application management, including deployment, upgrade, operations, and availability protection. Okay, what we want is to automatic application management on Kubernetes. So our architecture is like this. OpenCruise works in Kubernetes clusters. We mainly contains Cruise Manager and Cruise Demo, the two components. Cruise Manager, it contains controllers and webhook, and Cruise Demo works on Node, and it calls a CI interface, just like a Kubernetes do. Okay, this is mostly OpenCruise different with the upstream workloads. So the upstream workloads like deployment and stable set and daemon set, they just work as the controllers. Okay, but OpenCruise, it has Cruise Demo on Node, so it can do much more things than upstream workloads, such as image preload, InPlace update environments, and container restart. So OpenCruise mainly provides features in this area. It just like application workloads, multi-domain management, sidecar container management, enhanced operations, and application availability protection. So I'm going to introduce some key features in these areas. Firstly, I would like to introduce InPlace update. Actually, the upstream Kubernetes, it has the KEP InPlace rolling update since 2015. Okay, but the upstream worries about this feature. It may break the Kubernetes some infrastructure, so they do not implement this. But OpenCruise provides this feature, and you see the people here. They have already found OpenCruise that provides the InPlace update, the key feature in OpenCruise. Yeah. What is InPlace update? It compares with the recreate update, just like the upstream deployment when it tries to upgrade a pod, such as we're gonna upgrade the image in the pod from V1 to V2. Okay, the upstream deployment, it has to recreate the pod, which means the new pod is different from the old pod. It is a new pod, and it has new no name, IP, and just some an IP and volumes. Okay, but OpenCruise provides the InPlace update, which means we don't have to recreate the pod. We can update the image in the same pod object, and with InPlace update, we can avoid the additional cost of scheduling, allocating IP, allocating and mounting volumes. Besides, it has faster image pooling because we can reuse the most of the image layers on the same node. And when a container is InPlace updating, the other containers in pod will not be affected and remain running, which means When we have multiple containers in a pod, just like application and sidecar, when we're going to upgrade the sidecar container in place, the app container will not be affected, and it will remain running when during the sidecar container is upgrading. Okay. Second one is sidecar definition and injection. OpenCrews provide a CRD, names sidecar set. Users can define their sidecar containers in the sidecar set. Just like this, it has a selector, and contains the sidecar containers that should be defined, just like log collector. So after user define the sidecar set, when another deployment or replica set or some other workload creating pods, OpenCrews will inject the sidecar container defined in sidecar set into the pod, which means the sidecar set defines log collector, and the deployment may only have the application container in its template. But when pod creating, Cruise will inject the log collector into the pod, and finally the pod created has a log collector and the application container, two containers. It works somehow like the is2 injects the envoy container, but with sidecar set, users can define any container they want to any container matches the selector. It is more flexible. All right. This feature, it provides image pre-download. Actually, it is a CRI, which is the container runtime operation. But Kubernetes itself, it does not export a CRI interface to end users. End users can only use the pod object to when they want to create container, they only have to create pod, but they have no way to do more things to the container runtime, just like pulling image or restart the container or doing something else. But OpenCrews provide a CRD named image pull job. With the CRD, user can define their image that want to pull in on some nodes. Here is the selector for the nodes. They can define the selector, or with no selector. It pulls image on all nodes by default. All right. And when user creates the image pull job, OpenCrews will dispatch the job to each Cruise daemon on the node. So Cruise daemon knows which images should be pulled on the node. Okay. This feature provides multiple domain management. Actually, Kubernetes it provides pod topology spread constraints, but the pod topology spread constraints it only allows user to deploy pods into the into the nodes or the domains or zones spread. But with OpenCrews workload spread, users can define it refers to a deployment or a clone set of OpenCrews, and users can define multiple subsets. Which subsets could have max replicas? It can be a number or a percentage. So users can use OpenCrews workload spread to deploy their deployment, their pods into different zones, into different. All right, this is the top. Into different zones. and they can have a different percentage, so it can be more flexible to allow user to do the deployment in multiple domains. And this can be no more than available zone. It can be some stable and elastic resource pool. It can be used in more scenarios. This feature provides deletion protection. In Kubernetes, when we delete a CRD mistakenly, all CR of this CRD will be deleted. And just like this, we delete a workload or we delete multiple workloads. All pods belongs to them will be deleted. Or we delete a namespace mistakenly, all resources in the namespace, including pods or services, will be deleted. So to solve this problem, we provide deletion protection, which means we can protect CRD namespace and workloads from deletion. All users should do is to patch a label on the CRD or namespace or workloads, and it can protect it from cascading deletion. When user tries to delete a CRD or namespace, so user tries to delete a namespace with the deletion protection label, OpenCrews will help it to check if there is active pod under the namespace. And if there is no active pod in the namespace, so the namespace can be deleted normally. And if there is active pod running in the namespace, so it means the namespace cannot be deleted currently. All right. I have introduced the features in many of the areas.
Can I ask a question? So when you were talking about the CRI bit, do I understand correctly what OpenCrews is actually works in, like connects in the parallel to the kubelet, to the container runtime?
I'm sorry, I don't really get you.
Well, the next slide, the slide number 8, you briefly showed.
This one?
Number 8.
Okay.
Yeah. So in this picture, you have a cruise daemon and the kubelet both talking to CRI, right?
Yeah. Yeah.
So practically, when you're changing, you are starting a container by directly talking to CRI to restart it with a new image ID, right?
Actually, when a pod is created, it all create the image pooling, the container create is all done by kubelet, and the cruise daemon only watches the CRD we defined in OpenCrews, and it provides enhanced operations just like image pooling or container create, and it will not do the same thing as kubelet.
Okay. Oh, fine. Good. Thank you.
Okay. This is the OpenCrews adoptions. So most of our adopters is in China. In US, we currently have registered adopters just like LinkedIn, Lyft, and some other companies. In China, we actually have 6 in 25，应该Alibaba and Group, Ctrip and some other 25 more adopters, and I'm gonna introduce in 2 use case of the adoptions. One use case in Alibaba, OpenCruise manages almost all of the applications that have migrated to Kubernetes in Alibaba, which means OpenCruise now includes and manages millions of containers running in hundreds of Kubernetes clusters. For this figure, we use OpenCruise in Alibaba and OpenCruise mostly for the stateless applications, including web service, and advanced stateless mostly for middleware applications, just like Zookeeper and some MQ, some applications like this. Sidecar set mostly for the sidecar containers, like mesh container or some operations container, and advanced daemon set is for the daemon applications, just like CSI plugin and some network plugins, and node image per job mostly for the image prepool. This is what Alibaba use, and we also have the LinkedIn. It is an adopter from America. It proposed to use clone set for manage large-scale workloads, and they mostly use the key features like InPlace update and enhanced PVC support. LinkedIn, it has a specific scenario. It has a basic container for all applications. It should be defined in all ports, started before the application container, and even InPlace updated. The basic container should be InPlace updated before the application container can start to update. Which means the containers have each start and upgrade order request. Okay, OpenCruise community and LinkedIn users have feature requests and discussions in the issues, and we also have Zoom meeting to discuss about it. And finally, we supported the specific scenario with the InPlace update and the container launch priority. The container launch priority feature, it guarantees some pods, some containers in a pod should be launched, start and update before the other containers. Use this, and LinkedIn has supported their specific scenario. Okay. The final is our timeline. OpenCruise, it is open sourced in GitHub since 2019 and announced on KubeCon and CloudNativeCon China 2019. Usually we have a release every 2 or 3 months, and OpenCruise became the CNCF sandbox project at 2020 November. Finally, we completed the CNCF annual review this year, and we think it is now ready for the incubation. This figure is our contributions and contributors actively since our open source and till now. It has continuous active contributions. This is my presentation, and do you guys have any questions?
Thank you. From my side, no, I don't have any further questions.
All right. Let me see. Ricardo is not here. Okay. So this is our meeting this week.
Yeah.
Do you have any suggestions? Shouchen?
You asking me or Cenk?
Do we have an extra agenda tonight?
No, it's only one item in our agenda for today.
Okay.
By the way, please add your names into attendees list afterwards. All right, so if there are no other questions and we don't have any other agenda items, thank you very much for your presentation. And I think we can conclude on this today's meeting.
Okay. Thank you.
Thank you. Bye-bye.
Bye-bye.